At the end of the lesson, you are expected to identify E-insensitive region, discuss the process of setting boundaries, and appreciate the significance of support vector regression in machine learning. In our understanding of support vector regression, there are some useful terms that we have to study and we have to know by heart. It's because we use them to understand the essence of this algorithm. So we have here the kernel, hyperplane, the boundary line, and support vectors. So we're going to have them one by one. Let's first start with kernel. What is it all about? So when we say kernel, it is a set of mathematical functions. The function of kernel is that it takes data as an input and then it transforms the input into the required form. In support regression, we actually use a lot of kernels. So we have the linear, we also have the nonlinear, we also have the polynomial, and of course, we can never forget the radial basis function or RBF. So support vector regression uses RBF or radial basis function by default. Now, let's go to hyperplane. What is it all about? Hyperplane is actually a line that helps us predict the continuous value or our target value. So we mentioned this one in our previous video, and this is just actually a repetition of what hyperplane is. Of course, boundary line, these are the lines, the two lines that can be found above and below the hyperplane. And the distance of each line from the hyperplane is measured by E or epsilon. Let me write this one. So that's the boundary line. What about support vectors? Support vectors are actually the data points which are closest to the boundary line, and its distance can be minimum or least. So let's have this diagram for us to properly see what we mean by these terms. This one is the hyperplane. These two are the boundary line. And we have here, these are the support vectors. And these support vectors actually tells the shape of our hyperplane, and this tells us what would be the distance from this part going to this part. But of course, we could not see here the kernels because it's the input, it's the data itself that is being transformed to a required form so that we can process the data that is for the support vector regression algorithm. Okay, so we are set to go to understanding the E-sensitive region. So I guess I have to change the pen. Okay, so all right, so we have this one. So we're going to understand the insensitive region, I mean. So foremost, let's remember that support vector regression formulates the objective function. And in this kind of function, we are approximating the narrowest tube around our surface in such a way that we can also minimize the prediction error. And for us to be able to find the most possible value that can give us the narrowest tube, but at the same time, minimize our prediction error, we use this solution. Stated in another way, we use this solution so that we can be able to minimize the error between the predicted value and the actual value. So in short, the value of W here is the regularization function. Let me write here, regularization. I believe you already know what a regularization function is, and this is actually very important so that we can be able to properly process our data to avoid extreme values that could affect our prediction. So that means with all of the points in here, okay, so let's assume that there are a lot of points here, right? Okay, so we have here a lot of points. Now, in support vector regression, we are finding the narrowest tube that can be found around our function. So what this means is that we are actually trying to fit as many as prediction errors in the tube. And with that prediction, it's always very important to understand our constraints because these constraints would dictate the upper value and the lower value of our two margins. So Our constraints can be identified and processed using these two equations. For above the hyperplane, then we're going to use this one. And for below our hyperplane, then we're going to use this. And why is this very important? This is very important because this can tell us which of these data points will be considered for our prediction. And the data points that are above the upper boundary, so using this one, would not be considered. And those points below this one, for this equation, will not be considered for our prediction. But of course, the caveat here is that our tube should not be too narrow for it not to include substantial data, because when there are a lot of substantial data that can be found around our tube, then that's going to cause a lot of terrible problem in our prediction. So this is why in support vector regression, we are trying to fit the errors within a certain threshold. And we said that our threshold can be found using these two, the above and the below margins. So mentioning the margin, of course, we cannot avoid using the E-insensitive loss function. So let me write here so that you can properly see E-insensitive loss function. And this kind of function penalizes those points that are too far from our desired output. So for example, this one and this point are very far from our desired output, which is here. Our E here determines the width of our tube. When I say width, it means the distance from this point going to this point. So logically, when the value of this loss is higher, of course, there would be a lot of points that can be considered for prediction. Of course, when the value is lower, we can consider only not too many points for our prediction. So in short, when the value is higher, its tolerance is high. When the value is lower, its tolerance is also low. And when I say here tolerance, it is always the tolerance for the error. So it means when we increase the distance, it would mean also that our model is less sensitive to noisy inputs. And because it is less sensitive, it means that it becomes more robust. What is this for? Why do we have to study this? This concept of E-insensitive region makes support vector regression robust to outliers. It has a very good generalization capability, with that its prediction accuracy is high. One more thing about it is that it can be easily updated. After all being said and done, let's try this. What is E-insensitive region? How are the boundaries of the E-insensitive region identified? Please write your answers in the comment down below so that we would be able to have a very rich interaction of ideas and we can learn from each other. Do you want to know more about this channel? Just click these cards. You can enjoy our data science courses like Mastering Machine Learning Algorithm, Deep Learning Mathematics, the different data science algorithms, and a lot more. Here, you can always learn and upskill for free.